Alright, so what we're going to be doing here is we're going to be looking at how voltage and current work when we wire things together in series. So the first thing we're going to talk about is what it means to be in series. In series basically just means in the same path of current, meaning they're in the same loop, or we're going to use the term branch. So things that are in the same branch or path of current are going to be said to be wired in series. So all three of those terms mean the same thing. Wired in series, in the same branch, or part of the same path of current. All three of those things mean the same thing. So, what I've got here is instead of a voltage source like a battery, I've got a power supply. And we're going to be using this mainly because it's going to give us a steadier stream of current and doesn't have the same kind of fluctuations as a battery might. And what you can see here is how much voltage it's set to. So right now it's set to 5.7. It's very sensitive, so I'm going to crank it up to about 6 volts. There we go. And down here it'll actually show us how much current is running through there. Now with these light bulbs, they're not going to be giving us very much current to begin with, so it might be a little bit tough to see, but that's actually kind of nice the way it's rounding off. So that way the numbers will come out to be a little bit more cleaner. So we've got here, all right, cool. So what we've got here is a black and a red wire, and as we've talked about before, if you've been to some of the Zoom sessions, is that black is kind of our universal color coding for negative, and red is our universal color coding for positive. So what these two basically are is the positive and negative ends of a battery. So you can imagine that this is a battery, and you've basically got a positive side to it and a negative side. So we've got that. We're not going to connect those because that would be a short circuit, which would be very, very bad, because we would have one complete loop here, which would then, with practically no resistance, and that would be very bad for the power supply. I'd have to replace the fuse in the back of it. So we've got those, and we've got 3 light bulbs. So what I'm going to do first is I'm just going to hook up one light bulb. I've got some wires here, and for color coding purposes, I've got this kind of connected up like this. So we've got here this light bulb. So this is the black side. So what that means is that's going to connect the black side of the voltage source. So it's going to come over here, and so that's kind of showing us that this wire connects over here. And then I've got this wire here, and then this will be the red side, right? So just like the voltage source has a positive and negative side, the battery here is going to have a positive and negative side that we hook up to it like that. And we hook it up, and the light bulb lights. Now, what's cool about the light bulbs is that it does not matter which way the current flows through them. So that means the positive side and negative side can be different, right? So I can flip this around and hook up this way, and current will still flow. There are some things that depend on current direction, like motors. If you hook them up backwards, they'll spin in opposite directions. Sometimes they won't spin at all. LEDs, which are light emitting diodes, which I have on my speakers here. So you can see that little blue light, that little blue LED, only works when current flows through it in a particular direction. So if we were to do what we just did here and flip it around, then that LED would not light up. But we're lucky we're working with just light bulbs, so we're good with that. And what I've also got over here, so you can kind of see it right over here, is this voltmeter. So that's, I got this here in a little picture-in-picture all set up. So what we can do is we can actually measure how much voltage is across things. And what I've got are my red and black probes here. And so what we can see right now is that we've got 6 volts of current, 6 volts of voltage being applied to the circuit. And right now there's about 0.29 amps of current flowing through it. And so this is going to tell us how much voltage we're applying, and we can come over here and use these to see how much voltage we're actually using. Now, these wires are pretty good, so you can see we're losing pretty much no voltage as we go across, right? We got 6 and we got 5.9. I bet if I tweaked with this a little bit, I could get it to be exactly 6 on both of those there. Let's see. It's a very sensitive thing, and it rounds off pretty quickly. So let's see. Let's keep turning it down a little bit. 6. Nope, 5.9. A little bit more. A little down. And almost, just about. So 6 volts being supplied, about 6 volts being used. Now what we're going to do is we're going to take a look at what happens when we hook this up with another wire. So we've got a second bulb, and we'll put this one in here. So we got a black side and we got a red side. And now these should just give us the black side and the red side automatically, since we hook things up nice and neat like this. when we look it up now, well, now you can see, hopefully you can kind of tell, that those light bulbs are burning a lot less brightly. What I can do is I can hook up a light bulb separate on its own this way. Let me just do it this way. So we can kind of take a look at it like this, and hopefully you'll be able to see some relative brightness here. And yeah, you can kind of tell here that the light bulb hooked up by itself is definitely brighter than the two that are hooked up into the same branch. So the way we would classify this is not really by saying that this is a series circuit. All we would say is that these two light bulbs are wired in series. And we know they're in series because they're in the same path of current. As we go from one side of the battery to the other, there's only one path to get from one side to the other. So they're all in the same branch of current. And what we can see is that we're still applying 6 volts, but we've gone down in the amount of current, right? If we put this back here, before we had about 0.29 amps of current flowing through. Well, now we've got 0.2 amps of current. So we lost some current there. And before, so we're still supplying the same 6 volts here. But if we measure across each bulb, we get about 3 volts on this one and about 3 volts on this one. So conservation of energy seems to be happening here, right? Voltage is an amount of energy supplied. And we've talked about when we measure the voltage across a voltage source, you're measuring how much voltage you're applying. And when you measure the voltage across something else in the circuit, you're typically measuring how much voltage that thing is using. So we're supplying 6 volts, and we're using 3 volts here, and we're using 3 volts here. So that's kind of telling us that, okay, well, we're still using a total of 6 volts. We're still applying a total of 6 volts. So conservation of energy kind of holds true. And something else that's kind of, you should be kind of getting out of this is we put more resistors in series and the current went down. Well, the voltage stayed the same, but the current went down when we increased resistance. When we did that, right? So the voltage stays the same. So if we think of Ohm's law, V equals IR, if this stays the same and this goes down, that kind of means that the total resistance would have to go up. And that's a key difference here, is we want to know that when we add more resistors in series into the same path, the amount of current goes down. Right? Like we can add in our third bulb now, and we'll see that that should hold true as well. We're still supplying that same 6 volts. We haven't touched that dial. But now the current's gone all the way down to 0.16. And you should definitely be able to see that these bulbs are very almost, not even lit anymore. You can barely see the brightness there when we turn them on. We can definitely see it. There is definitely a difference there. But their brightness has diminished very much, as well as the current. Right? So with each bulb that we've wired here in series, we've gotten less and less current, which should kind of make sense, right? Like the more things you put in the path of the current, the more that it's going to slow down. We're still applying the same 6 volts, but now, let's see, how much voltage do you think is going to be across each one of these identical bulbs? All right, let's take a look. I got my probes on backwards, so we'll go here. And this time we've got about 2 volts. 1.9, we can round that up to 2. And here we've got 1.9 volts, another 2 volts. And then here, we got another 2 volts. So the same pattern we're seeing is holding true. Right? So the voltage is getting divided up. In this case, it's getting divided up equally because they're all identical light bulbs. We're supplying 6 volts. We're using 2, 4, 6. Conservation of energy holds true. A couple other cool things we can show you about measuring voltage is if I did backwards my probes here, right? So if I put the red probe to the black side and the black probe to the red side, you'd see that we're getting a negative amount of voltage here. And that just means that we haven't matched up our probes correctly. It's still the same amount. It's really just kind of a potential difference that we're measuring here, and we can measure potential differences, like any kind of difference. You can subtract the bigger from the smaller, or the smaller from the bigger, and that's really all that's happening here. It's not measuring really, it's not really affecting how much voltage there is. It's just telling us like a different, either a positive or negative based on that. It doesn't affect any of our stuff. But another cool thing we can do is we've been measuring voltage across like one component. You can measure it across multiple components, right? If I move my probe over to this side, well, there's still only one component in there, so we're still only using and measuring the 2 of the volts that are being used. If I move it to the other side here, well, now we've got 2 of those bulbs in there. So we're measuring the amount of energy being used by both of those. So it's everything across those 2 probes. So we're measuring 4 volts because each one of these is using up 2 volts. And if we go to the third one, again, if we go to this side of it, we've still only got 2 of the bulbs in between the probes. But if I go to the other side, well, now it's just like before. Now we're using up that same 6 volts. We're still applying 6 volts here, right? Let me see if I can get those probes in there. Yeah. In fact, here's even better, right? So this is showing us that we're applying 5.9 volts. There's maybe a little bit lost here from where the sensor is here to where the probes actually end up here. But we're applying 5.9 volts, and we're using a total of 5.9 volts. The only difference between this and one singular light bulb is now that they're sharing that amount of voltage. But one thing that you hopefully saw is that this ammeter here is measuring that same amount of current flowing through the whole time. The amount of current is the same everywhere. As you hopefully saw in your lab, we put ammeters here, we put one here, we put one here, so you could see that current going into each one and coming out of the voltage source itself was equal. And that's just kind of by the definition of series, right? To be in series means wired in the same path of current. Series, same path of current. Series, same current. Series, same current. So no matter what, they've just got all equal amounts of current there. And that is pretty much everything you need to know about things wired in series. The only thing that we didn't touch upon is that if we did have different amounts of resistance here, then we would see different amounts of voltage. That's kind of the key, is that right now all of these are reading 2 volts, 2 volts, and 2 volts. So they're sharing the voltage equally because they are identical light bulbs. They have identical amounts of resistance. If they didn't, then they would share it unequally. Things with more resistance would take up more of that voltage, which I will show you in the next video. So hopefully that was helpful. And now we'll take a look at what happens when things don't have equal amounts of resistance.